Good morning to everyone. Thank you for joining with me today. My name is Prabhu Teja and I am presenting my messy dissertation on machine learning driven threat detection framework for satellite cybersecurity. And this is the main agenda for this project dissertation. Coming to the introduction, as satellites are in space, monitoring and maintenance cannot be performed physically. Therefore, satellite use telemetry and tracking and command system to send information about system status, health, and location in the ground status. This research acknowledges that there could be insufficient quality label data that can be used to train supervised systems. Therefore, this research will be experiment with both supervised and unsupervised machine learning models to detect potential attacks on satellites through telemetry data. And there are some of the research questions to investigate and experiment with both supervised and unsupervised methods in predicting the presence of a potential attack, and to implement machine learning performance metrics that demonstrate the model's ability to match labeled data and demonstrate performance on unlabeled data. And this is the literature review. Modern satellite systems architecture has been drastically transformed from a rudimentary communication relays to a sophisticated multi-layered ecosystems that support global telecommunication, navigation, and Earth observation services. Current satellites are spread across various object requirements corresponding to different systems, features, and respective security applications. And mega constellations low Earth orbit of over 4,000 satellites in 540 to 570-kilometer altitude have become dominant paragraph with the SpaceX and Starlink are the example for that. And the space segment encompasses the satellite themselves, which have been evolved from basic repeaters to a sophisticated nodes equipped with the advanced processors, memory systems, and subsystems such as electrical power systems, altitude determination, and control systems, and thermal log systems and communication systems. In order to increase the speed to field and reduce manufacture cost, modern platforms, especially QSATs, implement standardized and modular designs. And the threat landscape includes kinetic threats and cyber threats. CubeSats and nanosats, concentrated by limited resources, are particularly vulnerable to export communications channels and open sources software vulnerabilities. And the European Space Agency anomaly detection benchmark reveals the difficulty in discussion security anomalies from operational variance, with the detection scores ranging from 0.0003 to 0.949. And the results from IoT ML IDS are important because IoT shares several characters with their satellite systems. These characters include limited power, processing speed, and distribution architecture. The evolution of a satellite cybersecurity through machine learning represents a critical advancement in protecting space-based infrastructure. As satellite systems become more complex and interconnected, the need for intelligent adaptive security measures became increasingly important. The integration of various machine learning techniques, from traditional static methods to advanced deep learning approaches, provides a comparison statistical defense strategy against the evolving threat landscape in space. And coming to the research methodology, data preparation, two columns, train, a boolean to specify whether it is a train or test record, and a segment, an index for the segment for discover irrelevant for the analytic reasons of the study and were subsequently dropped from the dataset. The channel column, originally of the object data type, was changed to a numerical form via label coding, and some of the duration bin, which was found during exploratory data and analysis, and also label encoded for more model compatibility. Stratified sampling guaranteed that initial class distribution were preserved in both training and testing sets, hence giving an equal representation of the magnetic class, avoiding biased model training. Supervisor methods involve using labeled data to train machine learning algorithms, and random forest was used in meta algorithm that builds multiple decision trees and aggregates their predictions. This model was trained with 500 estimators in parallel processing, and logistic regression, which was used as a baseline due to simplicity and interoperability as a comparison point for more advanced strategies. And unsupervised methods are used with the data is labeled and algorithms are supposed to learn discussing features by themselves. The image on the slides of the flowchart for this project pre-proposed and cleaned data is further processed with the feature scaling. Stratified sampling is then used to prediction the dataset into the training and testing sets. Then the sets are used to train the algorithms before performance evaluation is performed. And the hybrid semi-supervised methods combine the strengths of both supervised and unsupervised methods. And there are some of the semi-supervised models are KNN and XZBOD, LSCP, and PCA. And these are the findings and results. Like for CADC 0874 registered the highest average anomaly rate of above 36%, and some of the streams are 0890 and 0886 has the lowest number of streams have recorded extremely high anomaly rates. They reflects their highly contributed role despite low data volume. And pair plots indicated the anomalous observations was skewed towards large variance and skewed in specific channels, suggesting the multivariate models. And there are some of the low gas squares and significant upward shift medium, and NPICs for anomalous gaps featured specifically had much heavier tails for anomalous segments, making it a high signal feature for unsupervised detection. And these are the findings and results for supervised learning. And the best performing model was XGBoost. The model has a high F1 and recall. Random forest model also had compatible performance with the 0.94 on Kappan score of 0.8408. It was also possessed a high recall score of 0.9056. And unsupervised learning, according to table, kernel unsupervised models performed their unsupervised concepts, and a BOD achieved a slightly better balanced accuracy of about kappa score about than KNN, while a forest performed significantly worse than these. These indicates how hard it's to identify such a suitable security anomalous from normal fluctuations when there is no label data available. Hybrid approaches as shown in the table, and this shows how the use of multiple different detection mechanisms improves the performance of the system. And analysis and discussions through EDA, the most critical vulnerabilities in some changes and the time dimensions, a range of mitigation strategies were developed and validated. And PLS note, first author was testing how ML models would perform on satellite data using IoT data, since IoT data flows are similar to satellite telemetry. As space gets busier and more dependent with the increasing reliance on small satellites, their cybersecurity position is paramount. This project demonstrates as possible path of proactive, intelligent threat detection and above beyond traditional signature-based technology that fails under the evolving nature of cyber threats in space. And discuss limitations effective through their models like XGBoost may be too resource intensive for a real-time onboarding. Interoperability is still weak for unsupervised models with minimal feature of attribution. And for outside project scope, limiting is near-term utility to live systems. To recap, objectives were investigate the performance of various supervised and supervised learnings and develop a hybrid detection system to combine strengths and of supervised and supervised models. And these are the conclusion and future work. Using human in the loop active learning would be follow updates to refine model and comprehensively incredibly avoiding the limitation of fixed anomaly labels. And here are the key references I drew upon. A full list is available in my dissertation. I would like to thank my supervisors and the university for their guidance as well as open source of dataset contributions. Thank you for your attention. Thank you.